2 days ago. So it's going to be coming upward, and it loops around the sun. And then it comes back down, and it drops below that ecliptic. So people were asking me, well, why don't we see it all the time? Well, unfortunately for us, we rely on these space cameras, these telescopic cameras, on these space probes, these spacecraft that monitor the sun. Now, they were meant to monitor coronal mass ejections on the sun. Okay? They weren't placed out there to monitor planetary objects or objects like this stellar core. And a lot of people have asked me, they refer to this thing as a planet. The way that this object reacts with the sun, folks, there's probably no possibility that it is a planet. Some folks have asked about the term stellar core. Dr. Elbers started using this term many years ago. The reason being, a stellar core would be the core of a dead star. Very, very dense. Meaning, based on its size, it has an enormous mass. An enormous mass. And, I'll just put this in plain terminology, that core is structured to be hot, or to be around a hot environment, such as the sun. So many people ask me, why doesn't it burn up? Well, why don't all of our planets just burn up? Long story short, as long as these planets, Mars, Venus, Mercury, the Earth, as long as our inner planets always stay in motion in their orbit, we're not going to burn up. And we're not going to drift inward and be sucked in by the sun as long as these planets maintain their orbit. Now, if something were to occur, which it, based on physics, could not, if something would occur and this stellar core object would just all of a sudden stop, halt, then the sun would literally suck it right in. What would happen? I don't know. That's a pretty damn big object. The sun's a very violent place. So let your imagination wander on that one.